and then we'll go from there. So this is Greg Trautwein with Maritime Reporter TV, and we're very pleased to be joined today by Tom Risley, the Director of Energy Programs, Life Cycle Engineering, to discuss LCE's partnership with the U.S. Maritime Administration on a project to study carbon capture in the U.S. maritime space. Tom, I realize you have a long career in the alternative fuels business, and we talk about greenhouse gas emissions, carbon reduction, and ever-tightening IMO regulations regularly in our pages. Can you give us an overview today of the ship emission problem as you see it?
Sure. My first statement to you is it's complicated, as you might imagine, right? As I mentioned, back in the 1990s, the Navy, I was working in a Navy program looking at exhaust emissions, and the exhaust emission criterion that was of concern was NOx. And then as NOx became the topic, suddenly particulate matter, and it left from PM10, which is 10 microns, to PM 2.5. And suddenly there are all these protocols to do all the testing and so on. And so progressively, as people become more aware of health and environmental issues surrounding exhaust emissions, what I call the perfect fuel, which is diesel fuel, or petroleum fuel, is under attack, right? Is under siege. And never more so than now, when suddenly we are recognizing that greenhouse gas emissions need to be reduced. And so therefore it's impacting the energy sectors. Just, everything we do generates greenhouse gases. In the case of what's happened quite recently, of course, is this drive in the last 10 years or so to take a look at the space of CO2 emissions and figure out how to do the emissions. And what I think a tremendous program that has occurred in the maritime industry, of course, is the MEPC programs, the Energy Efficient Index, and the SEMP programs have dramatically reduced total overall emissions by improving ship efficiency, operating efficiency, and so on. Until now, those were driving. The realization, though, is that those will not bring the IMO 2050 50% reduction. Of course, if you follow the news, our administration has told IMO that we likely will be 100% greenhouse gas reduced by 2050. So there's a number of challenges that have now been tossed out, right? To the gauntlet is down, so to speak, for everybody, and it's complicated because the maritime industry is only 2.6% of the CO2 emissions for the world. Air industry, I don't know, 2.8. Everything we do on Earth, I just read 0.3 grams of CO2 for every email you send. So if you think about that and you put it in context, everything we do, there is going to be a tremendous rush. And I bring this out simply because while the maritime industry is doing their thing, everyone else is doing their thing, and they're all counting on the same sources, right? They're counting on, we're going to create e-methanol, we'll use renewable power. Well, the person down the road from you is doing the same thing for their utility, or somebody else is doing it for their data center, or somebody else. And so the bottom line is everyone's counting on that same renewable, and we don't have enough renewables. Plus we're transitioning it's just a lot. It's very complicated, as I said. And so in addition to working in your little space of the maritime, people have to also be aware of the bigger space as well.
Carbon capture and storage is increasingly discussed in the maritime and the offshore sectors. For those who might not necessarily be up to speed, what exactly is carbon capture and storage, and what are some of the main challenges in doing it efficiently, effectively in the maritime space?
Sure. So carbon capture and storage as a technology is something that has been worked on for quite a while now, and Department of Energy has had programs for over 25 years. And essentially, the premise is that you remove the carbon from either the fuel before it hits your energy conversion device, or you keep everything the same, and then you have your energy conversion device exhaust, and that, typically for marine space, it's diesels, and there are some gas turbines out there and boilers still, but and then you capture the CO2 and you sequester the CO2 on the ship until you can offload it. And so that's the premise behind carbon capture and storage. And so if you look at that in of itself, what it means is you have to add equipment to the back end of the system, tap the exhaust system. And many operators are familiar with this from the sulfur scrubbing side of the house. But if you think about it, CO2 in the exhaust stream is a much greater amount. I forget the exact number, 12%, something like that, of exhaust, where sulfur is a lot less. And so you're now talking about capturing a significant amount. And so, but the first challenge is most of these systems aren't marinized. Okay, and so you not only have the developing technologies of carbon capture, and there's 3 or 4 or 5 different methods that are currently under development or being used today, from absorption, adsorption, cryogenics, membranes, those types of things. But so the first challenge is marinizing, right? The second challenge really has to do with anything else on a ship, right? Because a ship floats, a ship has seaworthiness based on naval architecture, design, length, width, those types of things, or breadth rather, and so all those things matter. And when you put additional equipment on, you begin to have a challenge because space, volume, and you then start affecting potentially or impacting the trade, because if you do this, then you may not be able to carry as much cargo or those types of things. So that's part of it. But a corollary to this second challenge really is the fundamental science and chemistry behind this. When you burn a pound of fuel, you get 3 pounds of CO2. So if you think about it, the exchange is, I burn a pound, I get 3 pounds. So I'm gaining 2 pounds for every pound of fuel I burn, and I have to store it somewhere on the ship, because why would I capture it and not store it? So the idea would be I would capture it, store it, and then when I fuel again, I'll offload the CO2 at the same time, and so on, right? So that's the piece of it, right? That's relevant. And the third challenge, which combined effect of both, is this whole concept of the economics of the trade, right? Because anything you do now, you're adding weight from that you won't have yet, so you're going to have to work with ballasting. So it potentially impacts a number of things, right? It impacts the design, it impacts the cargo carrying capability. So you may not, 16, 20 containers less, whatever other cargo, you have to go a little lighter, right? So that's a problem. But secondarily to that, it's the challenge of everything you do on a ship, right? Not everything, but most everything takes a little energy. And so the other problem with this is you add a carbon capture system to it, and it's going to require some energy, either heat energy or electrical power and so on. So you begin this trade-off, because you imagine it's not there now, it will be there. So now guess what? I have to run more power, which actually means I'm generating more CO2. So there's a lot of trade-offs and a lot of thinking that has to go on to make this possible. And then the final challenge, of course, is what do I do with it when I've captured it, right? Because there's no infrastructure ashore, and Department of Energy is putting out, from some of the latest acts that have been passed, putting out a lot of effort and money to help develop the infrastructure to move CO2 about the country and to sequester it beneath the ground or beneath the ocean. So there's those activities, and so those are the challenges, right? What is interesting though is while that really sounds like a lot, try to picture an operator trying to figure out how to put hydrogen on a vessel because of its energy density, because and the other piece is, where do I get the hydrogen? So any of the other items, the new pieces and the other fuels, are fraught with many of the same challenges. So front end, back end. So the idea that when I spoke with Merit about this was somebody ought to be looking at the back end just to put the pieces together so that you can have a choice. Front end, back end, are there things that can be done?
There certainly are a lot of decisions to be made. So, so the deal with MARAD, can we take a little bit of a deeper dive into that? Can you give us an overview of the project? How much was awarded? What's the time frame? And what are the project deliverables?
Sure. So through MARAD's META program, we entered into a cooperative agreement, lifecycle engineering. We have a subcontractor, Petco, who is very knowledgeable about the carbon capture and basically carbon treatment space. They are working with us on the technology piece. And the idea is, an objective of the study is to evaluate various carbon capture methodologies, and to then take those and develop some conceptual applications for some ocean-going and inland waterway vessels, and then perform some techno-economic analysis. And again, this is really a scratch the surface piece. The LCE was awarded $120,000 from MARAD, and expect the project to conclude in October of 2022. Our deliverables really are two discrete ones, right? First is hosting stakeholder meetings and information sessions, because one of certainly the objectives of META and certainly Dan Yuska is to make sure that we educate the maritime community. That's one of the functions that they really like us to perform. And so we met with a number of companies, engine companies, operators, and technology companies to kind of bring the space together. We're anticipating a stakeholder meeting. It will be a joint one right now as it stands with Department of Energy and Department of Transportation, MARAD, to talk about marine carbon capture. And of course, finally, the other deliverable will be the report that we'll go through for all of the things that I've talked about.
Again, Tom, I truly appreciate the insight. So, as you know better than I, ship owners are remiss to put new technologies on their ship, and sometimes even more remiss to pay for them. I know that we're in the very early stages, but is there a way that you can put in perspective the types of equipment and the cost that will be involved?
Sure. So during, especially the natural gas project work for MARAD, where we were looking at doing a demonstration project on a towboat, we discovered there's some obvious concerns of operators that are not capital related, but more operational related. Those are important aspects. Where do I get the fuel for natural gas, and what's it going to look like on my vessel? Same thing would apply here. The operators are going to say, where do I store it? How do I store the CO2? And how do I get rid of it, right? And so that's a piece that has to be evolved. The other piece, which I've continued to hear IMO is considering and the industry is considering, a potential of carbon tax. Okay, carbon tax is an interesting thing because I'm paying to emit CO2 effectively. I've heard numbers, $100 a pound, right? But again, just to put it in perspective, it's $100 a pound of CO2. But because you burn you get 300 or 3 times the CO2, it's effectively $300 per ton of fuel. And so that is on some larger ships, I'm sure, quite a tidy penny of additional taxes. Now, the theory or thinking is that it's going to be used for pushing this technology further and researching and doing things. The other piece to this is that it's 28 years, right? And so 28 years. And so one of the things that perspective wise, if the equipment isn't even built yet, but the ships that'll be operating 28 years from now are actually on the drawing board today, how do I make a decision as to what do I do for anything, right? So there's a bit of paralysis in terms of, oh, well, and what you're seeing certainly in industry is they're buying secondhand ships to keep the thing going until the decisions can be made and which direction we're going to go. So those are some of the things. I will say that the capital expenditure for adding this equipment, there's a number of studies that have been done by various folks, $20 million, all those types of things. But what's really interesting today is the drivers, right? Because you have regulatory bodies, IMO, you have all these things, but there's another driver, and that is the supply chain folks. Because at the apex, you've got, Amazon, you've got IKEA, you've got all these companies that are that didn't exist before. So if you recall, my original paradigm with the background is that price differential matters for fuel. And so why would I use that fuel if I've already using a fuel, it's a lot cheaper. But now there's another element to this decision for an operator, right? Because if I don't do something, I may not be able to deal with some of the folks that have visions of zero emissions by 2030 or by whatever it might be. And so that's an additional driver that to many, like Maersk, right, who, they carry a lot of cargo that ends up in Amazon, or so those are I guess the statement that I would make, that while they don't want to pay for them, if they want to continue doing business and supply chains up and down in different directions are all getting asked this question: what's your life cycle analysis? And everyone wants to know what your greenhouse gas emissions are. So
you referenced it, and I read that you're creating a stakeholder group. Quite simply, who are you looking for? And if anyone wants to get involved, what should they do?
Well, what we've already created a little group to begin working. So, for example, in the ocean going side, we're working with International Seaways, and they're providing us information about their vessels so we can begin to do some modeling and concepts. We have a number of technology folks that we're talking with about carbon capture and sequestration, or storage, and we're finalizing some in the waterways. We are planning to do a joint DOE, DOT carbon capture webinar, and perhaps a couple of additional other meetings. But the way for anybody is to contact me directly. I'm more than willing to give them a briefing of where we're at and what we're doing, and see where that would go, and obviously include them on any other information and make sure they're aware when we do publish the final report.
Again, I can't tell you how much I enjoyed our conversation. I'm definitely going to be in contact in the future. You certainly have an interesting background, and like you said, this is a problem that's going to be here for a while.
Oh yeah, it's a modern day conundrum.